Great, thank you. My name's Gareth. Today I'm talking about WebRTC. Thanks for coming to hear my tech talk. So WebRTC, what is it? RTC is real-time communication. It's a way to allow users to connect directly peer-to-peer to communicate with each other. Prior to the development of WebRTC, there was Adobe Flash or Microsoft Silverlight, which were ways that users could have peer-to-peer communication, but they required a lot of plugins. If you remember the early 2000s, there was a lot of Flash plugins and things you'd have to install. No longer, that's not the case. So WebRTC doesn't require any plugins. It's a way to allow peer-to-peer conversation. So if you've ever used WhatsApp, Facebook Messenger, or peer.in, those are all built on top of WebRTC. Typically when we interact on the internet, you're making a request from your client, so whatever type of device you're using, whether that's your mobile phone or your computer, you're making a request to a server somewhere, and that server is going to send you information back. So for example, let's say you're building Gareth's Badass Chat Messenger, and I want to talk to my friend Andy over here. It would look like we're talking in real time because of the speed of internet and how fast a lot of our processing systems are these days. But in all likelihood, a simple way to build that, you would send a message to your server, and then on the application on Andy's side, he'd be retrieving messages and just checking for any updates constantly. So while it could look like real time, there's a server intermediary happening between the two. WebRTC gets rid of your server and allows direct communication. So WebRTC's mission is to enable rich, high-quality, real-time communication to be developed for the browser, mobile platform, Internet of Things, and to let all of them communicate. So if you're on an Android phone, I could still video chat with you from my Mac computer. There's a lot of interoperability that happens with WebRTC, which is super cool. So this is really great for JavaScript developers. It's built on top of 3 JavaScript APIs. MediaStream is the first one, which allows you to acquire audio and video. One of the requirements is that you have to be notified. So if you have ever gone to a video chat site and then you get a pop-up that says, this website wants to access your camera or your audio, that's a requirement that you have to accept so that applications can't just access your audio and video. So it's a security measure. RTC Peer Connection handles the audio and video communication between peers, as well as a lot of other pieces to that. So signal processing, codec handling, the peer-to-peer communication, security, and bandwidth management. That's RTC Peer Connection does a lot of the heavy lifting when it comes to these actual communication. The last one is RTC Data Channel, which allows for bi-directional communication. So let's say, for example, you were building a 2-player snake game. You could use RTC Data Channel as a way to let users play against each other because you'd be sending that data in real time back and forth. But in my opinion, really audio and video is where RTC shines. Having that immediate back and forth for audio and video is great. So in our previous example, talking about building a chat application, you can get messages pretty easily, right? That's a relatively small piece of data back and forth. But audio and video is very expensive to try and process back and forth. So if you get rid of a server, you have much lower latency and it's much easier to communicate back and forth. So how exactly would we implement WebRTC and how does it work? These are the 3 key pieces for WebRTC for understanding how it works. Now, these are different servers. WebRTC takes care of a lot of this for you, so these are not things that you necessarily have to think about or worry about, but to understand how it's operating under the hood, these are key pieces. So in NAT, network address translation, this is keeping your actual IP address private so that you can still be reachable online, but people don't know your exact IP. So utilizing a NAT, it's kind of like a firewall or almost like a screen name. You think back to instant messaging days, where people can find you online and know what your IP is because you have a public address, but that's not your private address. So everyone connected to the same Wi-Fi, we'd all have our own private addresses to our computer, but to making requests outside to the internet, there's some public address. And that looks like this. So there's the NAT server that kind of sits in the middle between your computer and the requests out and just gives you a public IP. A stun server is how you find out what your public IP is. So I could look and see what my personal IP is on the Codesmith Wi-Fi right now, but I might not know what my public IP address is. A stun server is just a way for me to find out that information, because this is all information I have to gather in order to establish a WebRTC connection. This is just an example of it's sending out to your Sun server. You find out what your public is, your public IP address is, and then it bundles all that together. The last one's turn. This is like a worst case scenario. It's a fallback option that WebRTC implemented in the event that you can't establish a connection between two clients. A turn server sits in the middle and processes the audio and video communication back and forth. But as you can imagine, that's super resource heavy, very expensive to run. Fortunately, based on like Google studies of this, Google is one of the big creators of WebRTC. That only happens 14% of the time. Like 86% of the time, they can establish a connection, so you don't have to worry about a fallback to a turn server. But again, these three pieces are built in and as a part of WebRTC, but just so you understand how it's working under the hood. So the only part that the server really plays a role in is the signaling. So let's say this is me on my browser, my friend Andy over here on his browser. If I want to make a connection to him, I need to find out A, what my IP address is, and B, what his IP address is, as well as certain configurations like, what can my browser accept for resolution? If I'm on a phone, that's going to be different than certain operating systems on a computer. So it goes through the process of like pinging the Sun server, getting that information, finding out the configuration of your browser, and then sending a request over to somebody else, gathering that information, and then trading that information. So now I know, okay, Andy can use this on his side, I have this on my side, and the server establishes the connection between our two browsers and between our two devices, and then steps back and is out of the way. So now there's a direct communication between two clients. And in the event of an unsuccessful connection, that's where turn would come into play. A common comparison is thinking about WebSockets. So WebSockets allow bi-directional data flow from a client to a server. So for example, in a chat application, you could use WebSockets as a way to get information back and forth and have constant updates. But WebRTC is for client to client. So these are not like competing things so much as they are complementary. For example, signaling, that actual process, there's no protocol written for that by WebRTC, so the developer is free to do however they want for signaling. If you wanted to send a regular HTTP request or use WebSockets, that's up to you as the developer to decide. So I'll do a little demo. So Andy's going to help me out here. Andy, you're running Ubuntu, is that right? Yep. If I can escape out of this, where is it? Where's my? Can anyone see my mouse? I can't see it. Ah, there it is. All right, perfect. And then open this up in a new tab. Because I've already done this before, it doesn't ask me for access to my video and audio, because you only have to require that the very first time that it pops up. So I'll join here, if I can find my mouse. There we go. Join. Now there's Andy.
Looks pretty real time.
So established here in that whole process was it signaled back and forth, figured out what our configurations were, and then established that peer-to-peer relationship. So now we can just communicate in real time without a server. Thanks, Andy. All right, so if you wanted to build your own WebRTC application, there's a couple of frameworks. Pure.js is a framework, EasyRTC. I think it might just be a library. But these are just ways to wrap the WebRTC function. That's not the right thing. API. Thank you, sir. The web API to make the build process easier, so you could get one of these up and running in a few hours if you wanted to. Otherwise, webrtc.org has everything you need to build all the way from scratch. Here's some resources that were super helpful in getting this talk put together. Google, they actually 4 days ago released the latest draft for WebRTC they're trying to have this standardized across the web. And prior to 4 days ago, it had been quite a long amount of time before they'd updated anything. So it's cool to know they're still working on this and trying to get it implemented. A lot of data is from like 2017, 2015, but They released a new draft, so they're still trying to get this up and running across the web as a standardized tool. Any questions?
So when you're using WebRTC, let's say if you're building a chat app on top of it, is there a way for you to store the data for database?
That's a great question. I'm not sure, actually. That's something I want to look into. I'm not sure why you would build a chat application on top of WebRTC. That's something me and my team at Consultaire are actually looking into right now to figure out if that's the best way to implement a chat application, because with the RTC data channel, you can send data back and forth. But my knee-jerk, or like my immediate thought is probably not, because the server is just there for error handling in the background. So I'm not sure where you would plug in to like store that data that's sent back and forth for long-term storage. Yeah.
So is that what like your iPhone FaceTime uses?
I'm not sure if Apple has implemented that for FaceTime specifically, but you could build a FaceTime application on top of WebRTC. Yeah. Or like a Skype. Any kind of video chat service can be built on WebRTC, or an audio one. So if you're just doing phone calls, that's what like WhatsApp does.